Imagine you're running a tech giant like Amazon or Netflix. With billions of transactions and a massive global inventory, why can't you simply run the entire operation on one giant Excel spreadsheet? It comes down to a problem called concurrency. If two people try to edit the exact same spreadsheet file at the exact same moment, the system panics. One person's changes simply overwrite the others. Then there is the physical limit of scale. The flat file starts to buckle, freeze, and eventually crash once you push past 1,000,000 rows. For a modern platform, 1,000,000 rows is just a quiet Tuesday morning. The flat file, the standard list of rows and columns, is a system designed for a human manually curating a small project. It is poorly suited for simultaneous global automation. For about 3 centuries, global commerce operated exactly like a flat file, but on physical paper. These bound ledgers were the original databases. Paper ledgers created a massive crisis of redundancy. If a customer moved to a new house, a clerk couldn't just update a central profile. They had to physically hunt down and rewrite that address across 50 different books, wherever that person's name appeared. When the global computing boom arrived in the 1970s, copying that highly redundant manual architecture into a digital format was impossible to sustain. Engineers needed a completely new mathematical blueprint. The solution arrived with the invention of the relational database, powered by a language called SQL. This provided a way to eliminate data redundancy. Looking at this diagram, you can see how the flat list is reorganized into strict tables. Every column is given a specific descriptive name and data type, and every row holds a single distinct record. This chart shows normalization. Data is separated, then linked using unique IDs. The primary key identifies a row, and the foreign key establishes a direct link. For a receipt, a customer's address is stored once. The transaction table just references their ID. The relational database operates like a bank vault. It is highly organized, rigid, and enforces strict rules to guarantee absolute data integrity. That is exactly why it forms the indestructible bedrock of global financial systems today. But the late 90s and early 2000s triggered an avalanche of new, semi-structured information: social media feeds, live chat logs, and rapid IoT sensor outputs. The strict rules of the relational bank vault became a liability. When systems attempted to process this chaotic, high-volume web traffic into rigid tables, they choked. This required the NoSQL breakthrough. Developers abandoned rigid tables entirely, moving to flexible JSON documents that could store complex, varied data on the fly. If the relational model is a bank vault, NoSQL is a messy desk. You can throw documents of any shape or size onto it, and you don't need a perfect blueprint to start. Intentionally ditching those rigid structural rules provided the massive scale and lightning-fast velocity required to power the modern web. Today, artificial intelligence and large language models have moved the goalposts. These machines must understand semantic meaning, moving past simple ID lookups. Both relational and NoSQL systems fail at this. If you ask either to find a sad song, they only search for the exact keyword SAD. They lack the context to know what sad actually means. Vector databases solve this by storing data as high-dimensional embeddings. It maps concepts spatially, clustering ideas like king and queen together based on their conceptual similarity. Because concepts are mapped mathematically in this 3D space, an AI can perform true semantic searches. It generates recommendations based on how closely related the ideas are, rather than relying on explicit text tags. Vector architecture moves us from merely storing cold information to mathematically mapping the deep complexity of human context. Modern systems orchestrate all 3 architectures simultaneously. In e-commerce apps, predictive product recommendations are pulled by the vector system. The massive backlog of customer chat logs is managed by the NoSQL system, and final financial transactions are securely locked away by the relational system. We evolved from simply writing data down, to strictly organizing it, to scaling it globally, and finally, teaching it to understand us.